Good evening, everybody. Tonight we're going to take a look at the classification of real numbers, just so that you can identify what category a real number falls into. And so when we're talking about integers or whole numbers, rational or irrational numbers, you know what type of numbers that we're discussing. So let's get started with today's lesson. Now, all numbers that we're dealing with in Algebra 1 are considered real numbers. Basically the classification breaks down into, initially, you're either a rational number or you are a irrational number. So all the real numbers that we deal with will initially be either identified as a rational number or an irrational number. So I'd like to really start off with the irrational numbers because those are mostly the hardest ones to make sense. I kind of like to think about somebody sitting and they did 2 pi r, and they were trying to find out what pi was, and they were doing the math, and they kept dividing and dividing and dividing, and they had 3.14, and then they added 1.5, and I don't even remember all the numbers, but they just kept going and going, and his friend came by and said, "What are you doing?" He said, "Well, I'm trying to write down pi, but it just keeps going and going." And he said, "Well, have you tried putting a bar over the top, like repeating, like as you see here with the 0.3 repeating?" And he goes, "I can't do it. Nothing repeats." "Have you tried putting it into a fraction?" "Well, there is no fraction that it represents. There's nothing that pi represents." "Well, is there a pattern?" "Well, there's no pattern." So his friend says, "Well, that sounds very irrational." And so I know that's a silly story, but hopefully that'll help you remember that if you can't write the equation, or if you can't write the number, in the form of a fraction, or you can't write the number with a terminating decimal, there's no pattern, then we consider those numbers irrational. They have no pattern. They make no sense. Obviously the most famous is pi, another one is e. The square root of 2, if you tried to find out what the number times itself would give you 2, you couldn't. You could not give us an accurate number. Square root of 17. These are all examples of irrational numbers. They cannot be represented with either a terminating decimal or a fraction. So hopefully that will give you a pretty big clue as if to whether or not a number is irrational or rational. What I'd like to now is start with is the middle of the group. See, if you're in this middle group, then you're a natural number, and you're also a whole number, and you're also an integer, and you're also a rational number. So members of the natural numbers groups are members of all 4 of these other subgroups. So what is a natural number? Well, I think it kind of makes sense. Something that you physically have. You can get a hold of an apple, or 2 apples, or 3 apples. They're natural. They are very normal numbers. And so if any of a number there is a natural number. Now sometimes we say that these are positive integers, which is also a true statement. And we'll talk about what an integer is in a second. But if you just think of all natural numbers as a whole positive number, not including 0. 0 is considered not natural. It's considered a whole number. The way I like to remember the whole number is the donut whole, 0 whole. And so if I am a 0, I am a whole number, which means I am not a natural number. So 1 is a natural number. It's a whole number. It's an integer. It's a rational number. 0 is a whole number, and it's the only special one that falls into the whole number, but is also an integer. An integer is just a positive or negative natural number. So for every natural number that you see, if you put a negative sign in front of it, that negative would then make it an integer. So 5 is an integer, 5 is a whole number, 5 is a natural number. Negative 5 is not natural, it's not whole, but a negative 5 is an integer. Negative 7 is an integer. Negative 12 is an integer. So just think about all your whole numbers, positive or negative, and we're talking about your integers. Well, the final category is most probably the most complex, and that's rational numbers. Those are all numbers that don't fit into the natural, whole number, and integer category, and they don't fit into the irrational numbers. So let's take a look at their requirements. So a rational number can be expressed in the form a over b. In other words, it can be written as a fraction. 1 over 2, 7 over 1, 9 over 10, or it can be written as a terminating decimal. In other words, the decimal ends. 1.5, 2.75, those are all decimals that end. If it doesn't end, then it must repeat. In other words, 1.3333 going on forever is written 1.3. 1/3 is the same as 0.3 going on forever, or we just put the bar over it. So I think we're pretty much done here. I just want to go back to the first slide. If you are a rational number, well, let me put it this way. If you are a natural number, you are a whole number. And you're also an integer, and you're also a rational number. If you're a whole number, that includes 0, then you're also an integer, and you're also a rational number. All integers are rational numbers. And finally, your rational numbers are included in the real number group, but only in the rational number section. Hopefully that makes sense, as you can see that the requirement to fit further and further inside the circle is the most restrictive. We'll have a chance to practice this tomorrow. I hope that you take a look at quiz number, let's see here, quiz number 22. It should be pretty straightforward. Good night, and I'll see you tomorrow.